So today we'll be graphing and solving for a sine equation. And the equation is y equals 3 sine pi x over 3 plus pi over 2 minus 3. So for the first part of our equation, we're going to have to identify the parent function. And for the parent function, we always start with something that's different than y. So in this case, we're going to be using f of x is equal to the regular sine to x. The second part of this equation is finding the amplitude. The amplitude determines how much an equation shifts or changes from its given points. And in this case, the amplitude is the number ahead of the sine or cosine that we're solving for, which is number 3. The next step we're finding is the period. And for the period, we always look to this part of the equation within the parentheses, and then we remember how in order to write that part it has to be 2 pi over the period. And since this part is 2 pi over the period, we can determine that it's equal to the pi over 3 without the x over here. And then we substitute the period for what we're trying to find, so we can use that as a variable of x equal to pi over 3, and we cross multiply, in which we have x pi is equal to 6 pi, in which x is equal to 6, therefore the period is 6. The next thing we're looking for is the phase shift. For the phase shift, we're looking to find how much an equation changes from right to left, which is also known as this part right here. However, since this x is not alone, we have to factor it. So we use what we have in the parentheses, put it down here, which is pi x over 3 plus pi over 2. And then we factor it, in which we pull out the pi over 3, parentheses x, and then we do pi over 2 divided by pi over 3, which is the same thing as pi over 2 times 3 over pi. These cancel out, which leaves you to 3 over 2. And then since this one's plus, it will be plus 3 over 2. And then for the phase shift, we're looking to find how much the function changes from left to right, which is only saying within the parentheses over here. And since this one says plus 3 over 2, the phase shift is actually negative 3 over 2. And the next thing we're looking for is the midline. For the midline, in order to find the midline, we have to use the vertical shift value, which is the negative 3 right here, which determines the midline in which the function will graph in. And then the midline, since it's also an equation, it would be y equals -3. And the next thing we're looking for is the domain and range. Domain and range. For the domain, it's always, like most of the time, gonna be from infinity to infinity. And for the range, it usually depends from your amplitude and your midline. So for the range, the typical equation is actually the midline minus the amplitude, comma, midline plus amplitude. In this case, since we found out before that the midline is -3, we can start with this point being -3 minus the amplitude, which is 3, comma, the midline -3 plus the amplitude, which is +3. And then we simplify from there, which gets you to -6 and then to 0. And then that's your domain and range. The next thing we're looking for is a function rule, since we already solved for everything that we can input in it. For the function rule, we always start with x, y, and then we use the transformations to set up a rule before we graph it. Continuing our function rule, so we use the horizontal compression here, and then we switch it, which is, instead of pi/3, it would be 3/pi x, and then we use the phase shift, in which it is -3/2, -3/2. And then for the y, we use the amplitude, which is 3y, minus the midline, which is -3. And then since this is our function rule right here, we're going to use, for our next step, we're going to use key points that we can plug into the graph to make it easier to graph. In a regular sine equation, for the key points, it first starts off at 0, 0, 0, and then the next one would be pi/2 over 1, or comma 1, and then the next point would be pi0. Next one would be 3pi 2 over, comma, -1. And then the next one would be 2pi, comma, 0. And now if we input the function rule for each part of the coordinates, we would find our new points. So for here, if we input 0 for here and then -3/2, it would give us -3/2. And then for 0 here, it would give us -3. And then for pi/2, we input that here. The pi's cancel out, and then we're given 3pi2, 0. And then if we input the pi here, the pi would also cancel out, and then we would be given 3, -3. And then if we input this, the pi's would also cancel out, and then that would give us 9/2, comma, -6, And then if we put this here, same thing happens. It will give us 6 comma -3. And then for graphing purposes, I will change all of this to decimals in order to make it easier to graph. -3 over 2 is equal to -1.5 comma -3. 32 comma 0 is equal to 1.5 comma 0. 3 -3 is the same thing. 9 over 2 is equal to 4.5 comma -6. And then this is also the same thing too. And then we will start graphing these on the other side. So before we graph it, I would want to write the key points here so that we know for quick reference. Now that we have our graph set up, I began plotting some points that we were already given on this side. However, in order for it to count as a whole graph, we would need 9 points, which would be a total of 2 periods. So if we continue the graphing pattern over here, then keep going, 1, 2, 3, 4, 5, 6, 7, 2 more points right here. And then we would graph that. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, yeah. Then we would graph it. And then that's our finished graph. But then of course we also have to label our points that we weren't given before. So -6, -3, -4.50, -3, -3. And then down here would be -1.5, -6. And then I might as well keep going. So 0, -3, 1.50, 3, -3, 4.5, -6, and then lastly 6, -3. And then that's our sign equation.